Here I will do an example about the change of bases. Let's say I have my old basis. Let's call it B0, which contains the following vectors. 1, 0, negative 1, 0. The second vector is 3, 1, 0, 0. The third vector is 0, 1, 0, 2. The fourth is 0, 0, negative 1, 1. That's my new basis. My old basis, sorry. Then my new basis is B1 is equal to 2, 0, 0, 0. Sorry, that's my first vector. 0, 2, 0, 0. 1, 1, 0, 0, 1, 0, sorry. And 0, 0, 0, 3. Okay. Now I have the following matrix. I have the following matrix, which is given by minus 1 over 3, 2 over 3, minus 2 over 3, and 0. 2 over 3, 2 over 3, 1 over 3, 0, minus 2 over 3, 1 over 3, 2 over 3, 0, and 0, 0, 0, 1. Okay. Now, I want to find the matrix B, which takes vectors in the old basis, according to the old basis, applies the matrix A to it, to this vector, and outputs a vector in the new basis. Okay. How do I proceed? So first I will draw a picture. So we have our old basis here. The first thing we will do, basically, we want first to go to the standard basis. Then we want to apply the matrix A, so we are also in the standard basis, and then we want to go to the new basis. Sorry, B1. Basically, we want our matrix B to do these three things. Okay. So first, I need to find how I take a given vector x in the old basis and how I can put it in the standard basis. To do that, what the only thing you have to do is you take your vector. So let's call it x, and you apply B0 to it. So B0 is the matrix which contains the old basis. That's all you have to do, and then you get your matrix in the standard basis. Then we can apply A to this vector, and so we get some output, which is also in the standard basis. Now we want to take our vector in the standard basis, and we want to have a vector according to the new basis, v1. And here you can't just multiply you cannot just multiply your vector y by v1. That's not possible. But basically what you will have to do is your vector according to the new basis will be equal to the inverse of that matrix B1. So B1, which represents the matrix with the new basis, times this vector y. Okay. So basically, your matrix B will be given by. So you have to go from right to left. Okay. First, you apply the matrix B0. If you apply your matrix B to a given vector x, it's like if you apply the matrix B0 to a given vector. Then you apply the matrix A, and then you apply B1 inverse. Okay. B1 inverse. That's what you do. Okay. So we know B0, we know A. To find B1 inverse, so we need to find the inverse. So let's just B1 is given by 2 0 0 0 0 2 0 0 0 0 1 0 0 0 0 3. Okay, recall that's our new basis. Sorry. To find the inverse of that, you write your matrix, and next to it you write the identity matrix. So there are several methods to find the inverse, but here we'll use this one. Now the goal is to find the identity matrix on the left side, so where we have our matrix, and yeah, we will use Gauss-Jordan to find the inverse. And then the right side, we do our matrix operation on the left side to get the identity matrix, and we will do the same operation on the right side on the identity matrix that we have at the beginning. And then once we get our identity matrix on the left, the matrix on the right will be the inverse of the matrix we had at the beginning. Okay. So here it's not that complicated. We can divide the first row by 2 to get the 1. We can also divide the second row to get the 1. We do nothing in the third row, and the last row we divide by 3. Okay, or you multiply it by 1/3. It's the same thing. And so we get our identity matrix. Sorry. Zero, 0, 0, 1. Okay, so pretty easy. And so on the right, the third row will be 1/2, 0, 0, 0, 0, 1/2, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1/3. Okay, and so the right side is already our inverse. So we get that B1 inverse is equal to 1/2, 1/2, 1/3. 3. Okay? Yeah. So here we have 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay? And now, so remember, we find B is equal to B1 inverse A B0. But remember, you go from right to left, okay, because it's matrix multiplication. And so we know B0, it's the matrix that contains the vectors in the old basis. We know A, and we know the B1 inverse. So if you calculate that, you should get that B is equal to, so you can't do the computation, it's just matrix multiplication. You should get the following: 1 over 6, negative 1 over 6, 2 over 6, 2 over 6, so we can simplify then. 1 over 6, 8 over 6, 2 over 6, negative 1 over 6, negative 4 over 3, 5 over 3, 1 over 3, negative 2 over 3, 0, 0, let's draw that, 6, 1 over 3, 2 over 3, and and 1 over 3, okay? You should click that. So it's just computation, okay? So basically, first you want to go from your old basis to the standard basis, and to do that you just multiply some vector x with b0, so your old basis. Then you apply a to it, you get some other vector according to the standard basis. Then you want to go to the new basis. You want to find the vector according to the new basis, and for that you multiply your vector by the inverse of the matrix that contains the vectors of the new basis. Okay? So you find the inverse of the matrix of the new basis, you multiply your vector by it, and then you get your new vector. And so the matrix that represents all that, it contains these 3 operations, and remember you go from right to left. Okay? So that's how you proceed. Thanks for watching.